How did it begin? By it, I mean all of it. Me, you, and even time. Even the most primitive human species emerged 6 million years ago, and this is nothing in front of the age of the universe. The Planck collaboration in 2015 estimated the age of the universe to be 13.813 plus minus 0.038 billion years. In the blink of an eye, the universe emerged from nothing. In 1924, Edwin Hubble demonstrated that ours was not the only galaxy in the universe. In order to prove it, he needed to calculate the distance of other galaxies. For this, he used the indirect method, as galaxies are so far away that they appear to be stationary. We can calculate the distance of a star if we know its luminosity and apparent brightness. Luminosity is the rate of radiation of light of a star, in other words, its power. Apparent brightness is how bright the star looks as seen from Earth than it actually is. Hubble noted that certain stars have the same luminosity when they are near enough for us to measure. He argued if we could find such stars in another galaxies and assume that they all had same luminosity, we could figure out their distance from Earth and hence could calculate the distance of other galaxies. All the measurements showed that most of the galaxies had redshifted, meaning they had moved away from us. Hubble declared his discovery that the universe was expanding. Most of the galaxies were moving away from our own, and the farther they were, the faster they were moving away from us. This is known as Hubble's law. If the galaxies were moving apart, this meant that some time before they were near each other, and in the distant past, there must have been some point when all of the matter in the universe was concentrated in a single point, a point having infinite density. Einstein's general theory of relativity predicts that the universe started at the Big Bang singularity. I have divided this diagram in 9 parts and I'll explain it part by part. Number 1 is the Planck era. Number 2 is the Grand Unification era. Number 3 is the Inflation era. And number 4 is the electroweak symmetry breaking. The Planck era, a period that occurred 10 to the power minus 43 seconds after the Big Bang. Before this, all the four fundamental forces, namely gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, were one and the same force, a single superforce. At the end of the Planck era, as the universe rapidly expanded and cooled, a series of symmetry breaking events occurred. The first, at the end of Planck era, gravity separated from the superforce. 10 to the power minus 36 seconds after the Big Bang, another such event took place, which marked the end of the Grand Unification era. The strong nuclear force separated from other two forces. Strong nuclear force is the force that binds quarks inside protons and neutrons. At 10 to the power minus 36 seconds, the universe expanded rapidly. The universe went through an astonishingly rapid expansion in which it increased in volume by a factor of 10 to the power 78. At the 10 to the power minus 11 seconds, electromagnetism and weak nuclear force finally separated. This is known as electroweak symmetry breaking. From there on, we have very firm theories as these are being tested in particle accelerators such as Large Hadron Collider at CERN. A millionth of a second after the Big Bang, protons and neutrons formed when the quarks had cooled enough to become glued by the strong nuclear force. Then came the first and the simplest atom, hydrogen atom. This process continued till lithium, and pretty much that's where it stopped. Now let us get back to the timeline diagram. The white, blue, and yellow dots are quarks. The red one is an electron, the grey dot is proton, and the light blue is neutron. In part 1, that is Planck era, gravity separates from other forces of nature at 10 to the power minus 43 seconds after the Big Bang. In part 2, that is Grand Unification era, the strong nuclear force splits at 10 to the power minus 36 seconds after the Big Bang. The temperature now is 1000 trillion degrees Celsius. The third part is known as the inflation era, as you can see some rapid expansion. In just 10 to the power minus 32 seconds after the universe formed, it expanded from the size of an atom to that of a grapefruit. The part 4 is known as electroweak symmetry breaking. Electromagnetism and weak nuclear force separated after 10 to the power minus 11 seconds of Big Bang. This is the point when quarks began to gain mass. Part 5. After 1 microsecond of Big Bang, the temperature was 10 trillion degrees Celsius. Cooling cosmos allows for quarks to combine to form protons and neutrons. Part 6. After 1 second of the Big Bang, temperature was 1 billion degrees Celsius. Neutrons began to convert to protons. Yes, that can happen. A video on that too will be dropped. Part 7. Electrons combine with protons and neutrons to form atoms, mostly hydrogen and helium. 400,000 years have passed and the temperature is 2700 degrees Celsius. Light begins to shine. Part 8. After 1 billion years, the temperature is minus 200 degrees Celsius. Gravity makes hydrogen and helium gas coalesce to form giant clouds that will later become galaxies. Part 9. Finally, the present day, 13.8 billion years with a temperature of minus 270 degrees Celsius. This video was just about the timeline of the universe. The quantum aspects of the universe will be discussed in a later video. And in that video, the exploration of the reason why the universe started as it did will also occur. Till then, goodbye and enjoy the beauty that God has made.